Okay, let's talk about this new section, 2.8, the present value of investments. How can you determine what you need to invest now in order to reach a financial goal in the future? And so this one's going to have two new formulas today, but one's sort of just a variation of one we're used to. And as we're thinking about this, we want to just think of in terms of our lifetime goals. Anytime you are earning an income, you should try to save at least 10% of that income. If you're not able to save 5 to 10% of your income into a savings account, then we are living not within our means. We're living outside of our means. So trying to save money, put away money periodically is a great idea. It's something we should all strive for. So the present value, blank value of a deposit that is made in the blank time. So let's go ahead and fill these in. So a present value of a single deposit investment. How much a blank blank deposit should earn at a specific interest rate in order to have a certain amount of money saved for a future savings goal. And then how much to save on a blank at a specific interest rate to meet that blank goal. This is making sure we can save something in the future. Okay. Present value periodic and present value single deposits determine what you need to save right now to have a certain amount in the future. And then what I mean by this formula is something we've seen in the past. If you can think of the compound interest formula, which is in the B equals this times the principal, we've just moved or manipulated that equation around to get this present value that I need. How much would I need? So now we're solving for that principal amount. So we're just going to go plug into this formula. Mr. and Mrs. Johnson know that in 6 years their daughter Anne will attend state college. She needs about $20,000 for the first year's tuition. How much should the Johnsons deposit into an account now that yields 5% compounded annually in order to have that amount? And then round your answer to the nearest $1,000. So let's go open up a Desmos. And let's plug in that formula. So this time we're putting the balance that they want in the future, 20,000, divided by the 1 plus their rate, and the rate 5% compounded annually to the power of annual compounding times, how many years was it? 6 years is when she's going to attend college. And so here's our new formula just manipulated around. And so if it's 14,924, we're rounding to the nearest thousand. So we're just going to say $15,000. This is how much they should put in an account now in order to have the 20,000 in the future. We had to round to the nearest thousandth. So in example 4, Ritika just graduated from college. She wants $100,000 in her savings account after 10 years. How much must she deposit in that account now at a 3.8% interest rate compounded daily in order to meet that goal? Again, we're rounding up to the nearest dollar, so be careful with these different directions on how we should round. Okay, so again, this is the same formula here. And we're going to go plug into Desmos in order for her to have 100,000 in the future. Rate is 3.8 daily. And she's saving for 10 years. And we're rounding to the nearest dollar. $68,387 is to the nearest dollar because we would round down. She should put $68,387 in an account now in order to save the $100,000 in the future. Now, most people don't have a lump sum of 15,000 or a lump sum of 68,000 just sitting around, especially right after you graduate from college. So most people are looking again at doing periodic deposits. How much should I put in monthly? How much should I put in weekly if I want to have a certain amount by a certain date? So examples 5 and 6, our last two examples, are going to be how much would I have to save on this regular interval, this periodic deposit? So Nick wants to install central air conditioning in his home in like 3 years. He estimates the total cost to be $15,000. How much must he deposit monthly in the account that pays 4% interest compounded monthly in order to have enough? We're going to round up to the nearest $100. Okay, so let's go try this new formula. Check out this new bigger one. All right, so we've got his monthly. So notice that the P here is what we're solving for. B is the ending balance of how much we're trying to end up with, of 15,000. And then annual interest rate, so the one, so times the rate, which is 0.04. Divided by compounding monthly. And then that whole thing is your numerator. So divide that by 1 plus the rate, compounded monthly, to the power of 12. And then how long in 3 years? So times 3. And then the minus 1. So I have to arrow down minus 1 for my denominator. So what this gives me right here is P is your periodic amount that we're going to have to be depositing monthly. Now, we go put this in here, it says to round up to the nearest $100, because normally when you're saving monthly, you don't tell your paycheck to save $392. You just say he should save $400 a month to make that goal. So we're going to round up to the nearest 100 because that's what makes sense in real life. You're going to round to a nice $100. You're not going to say $392 is the amount I'm trying to save. All right, last one. John wants to buy a boat in 5 years. He estimates the total cost to be $27,000. How much must he deposit monthly into an account that pays 5.9% interest in order to have enough money? And so this one's going to be a 5 years instead of this 3 years. And this one's a rate of 5.99%. And he's trying to have $27,000. So again, here's our new formula. 27,000 is the future goal. 0.0599% rate compounded monthly. 0.059 compounded monthly to the power of the monthly times he's doing 5 years. And then there's our little minus one. And so this one says to round up to the nearest $100 as well. And so he should save $400 per month to make that goal. And that's it. There's our new formulas. These are all the formulas for the chapter, and we are ready for the coming test. So I did make a formula sheet. Actually, Miss Donahue made it for us that we are going to now drop into the bin here for you guys to have access to so that you can remember which formula goes with which thing.